endpoint is now different than the travel time between endpoint back into the original. So this is what the magnetic field does to acoustic waves in the sound, and we use this information.
So it's fantastic. So it becomes a prediction model. What technology do you use to detect what's happening in the sun?
So we use satellite observations. We have what we call Doppler images of the sun. The images measure the velocity at the solar surface. The satellite's Solar Dynamic Observatory, and one ground-based instrument which is named GONG, mainly global oscillation. And one of the instruments is actually here in Australia, and they have 6 instruments that they keep observing the sun all the time. So these are the satellites giving us measurements. We take those measurements and we apply some mathematical models to these, assuming that we know what's inside the sun.
Yep.
What's the structure of the sun? We predict what's at the back of the sun.
And those predictions come true with pretty good accuracy.
We still have to work to improve it, to get the spatial correct.
So how long does it take an echo to travel from one side of the sun to the other?
Hours.
Now, can you use your model and your data to predict when there's going to be big CMEs coming out of the sun?
I would be very rich if I can do that. What we can see at the back of the sun with this technique that's called helioseismic holography is a big active region. A big sign of a big active region. And that active region can tell us a story, can tell us, okay, I'm big enough that I can flare, I'm big enough that I can generate a CME, but we don't know for sure if that's going to happen. The statistics stops at one stage. Yep. We know whatever is big should generate something important, something big.
One, two, three, four, five. 1, 2, 3, 4, 5. Good evening. This is VK3EKH, VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria with the regular Friday night broadcast, coming to you from the studios of VK3CSJ in Narre South. Broadcasting on prime frequency of 3541 kHz in the 80 metre amateur radio band, and simulcasting on 160, our medium wave service, on 1865 kHz SSB. Both transmitters running 100 watts, 160 into a vertical monopole, a Hushcraft MA160V down in the back paddock near the creek, and the 80 metre inverted V dipole, which is suspended at the top of the Nelly Tower. Both transmitters are an ICOM Pro 3, 756 Pro 3, and we're also broadcasting through the Melbourne TV repeater, VK3RTV Digital Channel 2. Welcome to all the viewers there on the TV. And we're also streaming on the YouTube channel, which can be found on the ASV website at www.asv.org.au under the Radio Astronomy tab. Go down to where it says ASV Radio Broadcast, click on that, and all the information you need to know about the ASV broadcast is there, although the email address still hasn't been corrected for yet. So if you're listening, Uncle Rob, Mr. XRA, you haven't fixed that up for me yet. Anyway, good evening everybody. Trust that everybody is well, and that nobody has had any serious damage today. I'll just mute that because there could be a bit of an echo thing going on. And yeah, so we had no major issues here. Both towers and both antenna systems survived the wind. I recorded up to about 85 kilometers an hour, so that didn't particularly worry me too much as far as any damage that could occur to the antenna system. However, it's sad to hear that Lee, VK3GK, who's about 600 metres away from me, suffered some damage. He's also got two towers on his property, or at least he had two towers. But yes, he's one of his towers bent over, went belly up, midstream. It went over like a matchstick. And unfortunately, the real disaster that came from that episode this morning was that he has a stepper IR on that antenna. The what's the model number? DB8E, or is it DB18E? You know, the big stepper IR, and it's a write-off. Unfortunately, it is a write-off. So. Tower is gone and the stepper IR, and that was 600 metres away. So, but Lee's on top of the hill from here at Pound Road, and he would have received the full brunt of the cyclonic winds that came through today. But we've been here in this property at Narre South for 11 years, and we've had some pretty windy days down here in the valley. But I still haven't got to a point where I'm winding the towers down. But you know, lesson to be learnt from Lee's tower damage this morning. You know, if you know it's going to be gale force winds around, good idea to wind the tower down either way. So we may need to get into the habit of doing that. Anyway, I know Lee will get that all sorted out. Alright, we also have an email address. If anybody wishes to send reports, articles or anything of the like, the email address to the station is vk3ekh@gmail.com, vk3ekh@gmail.com. I'm getting it down pat now. I keep thinking of the older email address. Alright, And we also have a chat window too, the Discord chat window. The chat window can be found on the same location as the YouTube channel at the ASV website, www.asv.org.au. Alright, for those who are tuning in for the first time, g'day to David there who's also listening, and Cassiopeia, Nebs. Howdy doody. Fancy standby screen on YouTube. Well, hopefully it'll be me right now. I'm hoping tonight will go a little easier for me. I did spend just a little bit more time getting things sorted out tonight. I've got images and pictures to show. We've got the podcast tonight from astrophys.com. It's only a very short podcast tonight, not a very long recording. Podcast number 14, Dr. Elena Donner, and she's talking about sun quakes. The feature interview is from Australian Space Research Conference, where Brendan spoke to Dr. Elena Donner, and from Monash University, who is using maths and solar satellite data to detect sunquakes, and using phase shifting can accurately predict the appearance of active regions appearing around the eastern limb of our sun as it rotates. Marvellous research that Elena is doing. So we'll be cutting to that interview very soon. Excuse me. We also have the latest solar report from Timothy Skov, our space weather woman, who has a radio call sign of WX6SWW, Solar Space Weather Woman. That's what that is. Good on her. G'day to Timothy if she's watching over there in the United States at this odd time it would be for her. Anyway, we've got a latest report from Timothy to also screen a little later on. So, having said all that, let's just quickly go through what the ASV is all about. And if you've never heard anything about the ASV, well, now you're going to hear it. One day I'll get this all recorded, and I can just sit here and listen to myself waffling on. Anyway, briefly, and of course with a lot of the restrictions now removed from our COVID thing, access to the dark sky site is looking up. Pardon the pun. The Astronomical Society of Victoria was founded in 1922 and comprises some 1,600 members throughout Victoria, states of Australia and overseas. Membership of the society is open to all persons with an interest in astronomy. The Society's objectives are to encourage the study and practice of astronomy and to disseminate the knowledge of the science and to provide greater facilities for the study among its members. Meetings are usually held on the second Wednesday of each month except in January, where the latter being held on a Saturday night. Meetings start at 8 p.m. sharp at the Mullier Hall, National Herbarium, in Burwood Avenue, Melbourne, near the Melbourne Observatory, which is located adjacent to the Shrine of Remembrance. Parking is available in Burwood Avenue, Dallas Brooks Drive, and within the observatory grounds near the Great Melbourne Telescope House. Admission is free and visitors are most welcome. And I suspect that it is hoped we'll be getting back to the Mullier Hall next year, now that things are cooking. So we'll keep you abreast of when ASV has rebooked the herbarium for hopefully next year, and everything will be all back to normal in that sense. Privileges of membership include the right to borrow books, periodicals and other publications from the Society's extensive library located at Melbourne Observatory, receipt of the ASV's newsletter Crux containing articles, news, observing notes and the like, and the free provision of the Astronomical Yearbook. The yearbook provides data for local observations, informative summaries of various celestial objects and other general astronomical information. Access is available to telescopes on members' nights held regularly at the Melbourne Observatory. These instruments include the Society's 300mm equatorial reflector and a 300mm portable reflector. The 200mm refractor managed by the Royal Botanic Gardens and a recently restored photoheliograph are also housed at the observatory and are accessible as well. Regular Society Club Night meetings are held on the first and last Fridays of each month, which would be happening tonight, at the Society's property located in Burwood. Members are encouraged to use the Society's instruments located there in order to gain first-hand experience in telescope use. And these instruments include a 508mm equatorial reflector and a number of smaller reflectors. Members are also encouraged to make use of the Society's country property located near Heathcote and some 90-minute drive north of Melbourne, 2.5 hours if you're out where I am. The Leon Mel Dark Sky Site, LMDSS, offers superb views away from the light-polluted Melbourne and is an ideal spot for visual observing in astrophotography and radio astronomy. Members are encouraged to make and use telescopes. Advice and help on both matters are provided willingly to newcomers desiring to do the same. Instrument making is only one of the number of common interest activities catered for within the Society. Various activities addressed include deep sky observing, astrophotography, lunar and planetary observing, auroral, meteor, comet and variable star observing, radio astronomy, computing, cosmology and astrophysics, historical studies and research and astronomy in general. Contact details for various section directors are provided in the yearbook, or you can get further information or obtain further information by writing to the Secretary at the Astronomical Society of Victoria, GPO Box 1059, Melbourne, Victoria 3001. That's the Secretary of the Astronomical Society of Victoria, GPO Box 1059. That's 1 minute to 11. Melbourne, Victoria 3001. Or you can go straight to the website and all will be revealed. That's www.asv.org.au. And having said that, let's just have a quick look at the homepage of the ASV and see what they say. Welcome to the Astronomical Society of Victoria. The Society is based in Melbourne, Australia, and includes city and country dwellers. I can't read with those glasses. There's a membership tag, so if you want to join the Society, it's all there. Click on membership and it will be revealed to you. Everything is via PayPal, easy peasy, Japanesey. Now, a special note for members below. LMDSS now open, but bookings are required. So if you are a member of the ASV, a ticketing system is in action, all because of the restrictions that still apply, government regulations for obtaining access. So yes, well that's there, but nevertheless we are back at the ASV, Dark Sky Site. Oh dear. Anyway, there's a bit more information there, all gleaned from the ASV website, so if you want to follow up with all that, just go to www.asv.org.au. Where is everybody on the chat window tonight? I mean, I can only see Cassiopeia there. Hell's bells, there's nobody on the chat window. It's very unusual. There's always a swag of folks there. And yes, there's only one email at this stage, so maybe I'm just talking to myself here. I got blown away today. Alright, enough of that. Now, what time is it? It's 1:15. I think we could probably throw in an article before going into the podcast. Let me see, where shall I start off? I think I've got this is reasonably short. I've got a picture for this too. Let me see if I can just cue that up on vMix first, so I can bring that up in just a moment's notice. So that's ready to go. Now the article is published 11 days ago by Ben Turner. Astronomers spot dark matter creating eerie clones of a distant galaxy. This is from the www.livescience.com website. The cosmic triplets were formed by the warping of light around a gigantic unknown mass. I'll bring up that picture now. Just a sec. And that audio disappears again. Alright, so we should be seeing an interesting image there on our YouTube channel and on the TV. Alright, so what you're seeing there on the screen is the images can be seen here as two closely mirrored galaxies in the center of the picture and a third image higher up. That's what we're talking about. Astronomers have finally explained three perfectly identical galaxies in the deepest recesses of space. The cosmic triplets are actually just one galaxy, but its image has been multiplied by dark matter. The galactic doppelgangers were discovered by accident in 2013 by the astronomer Timothy Hamilton of Chauncey State University in Portsmouth, Ohio, while analysing data from the Hubble Space Telescope. Hamilton found two identical galaxies, one the mirror image of the other, sitting right next to each other in space. Not only did the two images have the same shape, with both having the same star-fleckled galactic centres, but they were also streaked with the same dark parallel lines. The mystery only deepened when Hamilton spotted a third galaxy not far above them that was identical to the other two. "We were naturally stumped," Hamilton said in a statement. "My first thought was that maybe they were interacting galaxies with tidally stretched out arms. It didn't really fit well, but I didn't know what else to think." Now, after 8 years of speculation, Hamilton and his colleagues have finally hit upon a satisfying explanation published in a study May 17 in the journal Monthly Notices of the Royal Astronomical Society. The eerie cosmic clones are one and the same galaxy, located 11 billion light years from Earth. But the gravity of a huge concentration of dark matter is bending the light from the distant source into three images. Dark matter is a mysterious, invisible substance believed to make up most of the universe's matter, and scientists hypothesize that it's the glue that prevents galaxies from flying apart. Einstein's theory of general relativity describes how massive objects warp the fabric of space-time. Einstein explained the idea that gravity isn't produced by an unseen force, but is simply our experience of space-time curving and distorting in the presence of matter and energy. This curved space, in turn, sets the rules of how energy and matter move. In the case of these galactic triplets, light travelling through an extremely curved region of space-time travels in a curve, warping and twisting through a gigantic funhouse mirror until it merges at three exit points at three perfect copies. Amazing. Think of the rippled surface of a swimming pool on a sunny day, showing patterns of bright light on the bottom of the pool. Lead author Richard Griffiths, a physics professor of University of Hawaii, said in a statement, These bright patterns on the bottom are caused by a similar kind of effect as gravitational lensing. The ripples on the surface act as partial lenses and focus sunlight into bright squiggly patterns on the bottom. By looking at the region of space close to the images, the researchers were able to identify the culprit behind the unusual lensing effect. A dense blob of dark matter belonging to a cluster of galaxies 7 billion light years away from Earth and situated between Earth and the galaxy whose light was being bent. Using a specifically designed computer program, the physicists calculated the distribution of this dark matter by studying how it had stretched the three images of the galaxy. They concluded that for the images to appear as they do now, the dark matter would need to be smoothly distributed across the light-bending galactic cluster, a result that not only helps them to explain the images, but also gives them a fresh insight into how dark matter may be dispersed throughout the universe. We know its dark matter is some form of matter, in brackets it was, but we have no idea what the constitution or what constitutes the particle is. So we don't know how it behaves at all. We just know that it has mass and it's subject to gravity, Griffiths said. The significance of the limits of size on the clumping or smoothness is that it gives us some clues as to what the particle might be. The smaller dark matter clumps, the more massive the particles must be, he says. Well, that's the end of that article. So, that's astronomers spot dark matter creating eerie clones of a distant galaxy, which happens to be the same galaxy. And you can see it there perfectly well on the high definition image there on the RTV repeater. Doesn't that look good, guys? That looks great. And also on YouTube. Alright, back to me. Oops, that's the wrong thing. Don't close that. We'll lose the YouTube. Where are we? VMix, back to me. Sorry about that. Alright, we're back on the air. Okay, time is 10:22. And we do have, yes, we do have a couple of, we have John, VK3BLX. Okay, John, he'd be watching TV as well. Good evening to all, he says. G'day, John. All right, now let's go ahead and get this podcast out of the way. All right, so we are about to go across to Dr. Elena Donner, Donea, and Astrophys number 14, episode number 14. She talks about sun quakes, and it's only a very short interview. As Brendan points out at the beginning of the interview, the recording he did with Dr. Elena was not too long after a presentation of some sort in a hall. So there is a little bit of background noise being produced by a lecture going on. So obviously where Brendan did the interview wasn't interrupting the people in the hall listening to whoever was talking. It was done somewhere away from that, but you can still hear on the odd occasion the noise in the background. But I think Elena comes through reasonably well. So I hope the transition tonight will go okay, because I know there's been a few issues with the audio side of these podcasts. Alright, you're tuned to ASV Radio. This is VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria, with the regular Friday night broadcast on 80 and 160, Melbourne's TV repeater, VK3 RTV, Digital Channel 2 HD, YouTube, and everywhere else you can possibly imagine. Okay. And thanks to Ian, VK3QL. That's just a special one there. And of course to not only Ian but to Neil. All right, let's get this going. All right, stand by. I'm going to bring up a slide, and where's it? And before I do that, and of course, where's my audio file? There it is. And we should be able to do this. Hang on, getting there. Kill that.
Dr. Donner, it's been fantastic speaking with you.
Yeah, thank you very much.
That was Dr. Elena Donner. Elena works at the School of Mathematical Sciences at Monash University as a senior lecturer. She's a member of the Monash Centre for Astrophysics and teaches large classes of engineering students, advanced engineering mathematics and science students. She's an expert in helioseismic holography, a mathematical method which can tell you how loud is the sun. She can detect solar quakes in satellite images from state-of-the-art instruments. Thank you very much.
Okay. One, two, three, four, five. Where's my audio? All right. Apologies for that. I have done myself an in-service here. That should have. What did I do there? Sorry about that, ladies and gentlemen. We've just got a small technical issue there. Yeah, I made sure I had that right, but it looks like I didn't. Damn. Alright, I only, for some reason, I did the, when I did the audio editing on the sound file, yeah, when I did the audio editing on the sound file, I edited only Brendan talking, and what happened to the rest of that interview? That should have been there. Oh god, damn these things. There's always some technical issue that just does it to you. I know how a workaround, but I'll have to find the other file. Alright, well, alright. Just stand by while I, what we'll do is we'll run with Tamitha's solar report. So I'll bring up Tamitha, and that should be able to go without any problems. This report goes for 11 minutes, and that'll give me time to find this audio file, hopefully. Let's see how this works. You're tuned to ASV Radio, VK3EKH.
Everything's quiet right now, but there's some new regions rotating into view, and it's about to get busy. Those stories and more in the news this week. This space weather forecast is sponsored in part by Millersville University. Come get certified in broadcast space weather. Visit millersville.edu/SWEN. Space weather this week is definitely sticking to the quiet side. As we take a look at our Earth-facing disk, you can see we have that big coronal hole that was sending us some fast solar wind over the past couple days. That is now rotating off of the sun's west limb, and we haven't seen a boost to storm levels, just really active conditions, kind of sporadically, and that's about all we're going to get from this region. And when we take a look at the west limb, there's really not a lot going on. But as we move to the east limb of the sun, take a look at all the bright regions that are beginning to rotate into Earth view. We have region 2886 and region 2887, and 2887 especially has been firing off some solar storms, and as we look past that around the 20th and even into the 21st, we're seeing regions both in the south and in the north. These are likely going to be sunspots and given designations as well, and we have seen some solar storms being fired off for there too. So expect the activity to be boosting here, as well as that solar flux. We're already seeing it rise into the high 80s. It'll easily get into the 90s and possibly triple digits here within the week as we watch these regions. So amateur radio operators and emergency responders, rejoice, because that propagation on Earth's day side should increase, and aurora photographers, keep your fingers crossed. There may be some aurora in your future. Switching to our M-flare threat meter, as you can see, the X-ray flux over the past week has been pretty low, and therefore by proxy the solar flux has been low. We've been sitting in about the mid-70s over the past week or so, but if you notice that right around the 20th, you start seeing that X-ray flux rise a little bit. That was from region 2886 and 2887 as it began to rotate into Earth view, and sure enough, that X-ray flux and the solar flux is going to continue to ramp up over the next few days. Possibly into this next week, we could actually be hitting the triple digits. Now, we also may be seeing some flare activity here soon. We're not seeing a lot of it yet, but as we continue to ramp up almost to the seafloor in X-ray flux level, boy, that tells you we've got some busy active regions that could be giving us quite a show. Switching to our solar storm conditions, if we go all the way back to the 12th, you can see we actually got hit by a pretty decent solar storm. This one made it up to the G2 level and gave us some gorgeous aurora clear down to places like Omaha, Nebraska, Iowa, and even Oregon. And it was due to that solar storm that was launched back on the 8th and into the 9th. Sadly, it didn't last all that long because it wasn't as great of a direct hit as we expected, and so it was over all too quickly. But meanwhile, as things began to die down, we got hit by a couple other mini solar storms, and then we got hit by some fast solar wind, and that kind of kept us at unsettled to active conditions sporadically, clear on and off until about the 20th when things began to finally settle down. Since then, we've had a little bit of a bump up due to some fast solar wind from that one coronal hole I talked about that's now disappearing off of the sun's west limb. And as that begins to wane, now we're back into quiet conditions, and it looks like here is where we're going to stay for a little while until those new active regions start sending us something more. And during this G2 level solar storm that we had about a week ago, even though it didn't last very long, there were so many gorgeous aurora photos, and I don't have a chance to show them all, but I have to highlight a few because they're just so stunning, like this one from British Columbia. What a romantic scene. These are some of the best shots that we've gotten from this new solar cycle. And on top of that, we had gorgeous shots from Norway. An aurora was seen in Iceland. And as we go over the pond to the Western Hemisphere, it was seen all over Canada, including this gorgeous shot from Quebec. And it was seen in Ontario. And it was seen all over Manitoba. Next week, I will highlight more shots from Manitoba, including other places in Canada, because there's just too many to show. And it was also seen in Saskatchewan. And of course it was seen in Alberta. And more shots from British Columbia. And as we dip down into the States, oh my goodness, it was seen in so many different places. Here's a gorgeous shot from New Hampshire. And it was seen in North Dakota. Lit up the skies in North Dakota. And it was also seen in Minnesota. And it made it to Iowa and Ohio. It even dipped clear down to Nebraska. And in the skies, flying out of Denver to Cedar Rapids, it was seen on a United Airlines flight. And it was also seen in Washington State and clear down in Bend, Oregon. So what else does our sun have in store for us this week? Well, this is Stereo A. It's our partially far-sighted monitor. You can see here's Earth, here's the sun, and here's Stereo A staring at the sun just a little bit from the side. And when we take a look at Stereo's view, you can see in the south, region 2886 and region 2887, well into Stereo's view now. But also look past that on the east limb. You can see 2 regions in the south, and look in the north, 1, maybe even 2 regions in the north. And if you pay attention, that's 4 different regions that are all actively gurgling and burgling. Do you see that? They're even firing off a few solar storms here and there. So things are going to get very busy here over the next few days just in stereo's view. And that means in about 3 or 4 days, we're going to start seeing these regions rotate into Earth view as well. They're going to boost that solar flux. They're likely going to be still firing solar storms, and we may have some flare players pretty soon. So everybody hold on to your hats. Switching to our moon, we are now coming out of a full moon on our way to a 3rd quarter, and by the 28th, the moon will still be about 50% illuminated. So you night sky watchers, if you want to catch those dim objects in the sky, you're going to need to check your local rise and set times. Switching to our solar storm conditions and aurora possibilities over the coming week, everything this week is going to pretty much stay in the green, and that's because we don't have much going on. There's no solar storms in the forecast. So at high latitudes, NOAA's expecting unsettled conditions, but we have up to about a 20% chance of a minor storm. But take this with a grain of salt, because likely it's going to stay between unsettled conditions to possibly even quiet conditions at high latitudes. Now, at mid latitudes, the story's pretty much the same. We're looking at unsettled conditions, possibly even just normal conditions, with only about a 10% chance of active conditions over the next 3 days and possibly over this week until we see those new active regions that are rotating into Earth view kind of rotate into the Earth strike zone and maybe launch a solar storm or 2. So then we could actually get some fun for your aurora photographers. But meanwhile, it looks like this week you're going to need to kind of sit it out and just allow those amateur radio operators to enjoy some quiet time on the bands, especially as that solar flux begins to boost. Switching to your solar flare and particle radiation storm outlook over the coming week, believe it or not, with all the new active regions rotating into Earth view, we are not completely in the green when it comes to big flares. We have 3 numbered regions on the Earth-facing disk, and it's region 2887 that's beginning to be a little bit of an M flare player. So GPS users on Earth's day side, we do have a small risk right now for radio blackouts, about a 10% chance of M-class flares, and this risk will rise easily over this week and possibly get worse into next week. So enjoy this little time off that you have right now before things start ramping up a bit. The one nice thing is that the solar flux is also ramping up. We're sitting at the high 80s right now, and we're going to be ramping up into the 90s and possibly into triple digits within about a week from now. So amateur radio operators and emergency responders, enjoy increasing propagation. We're going to be moving from marginal into the good range for radio propagation on Earth's day side. Now, also because we are still climbing out of solar minimum, the cosmic ray flux is a bit more intense than we'd like it to be, so you frequent flyers, and this does include air crew who fly over 800 hours annually and fly at high altitudes and high latitudes, you are in the marginal range. This is the D2 minor range for radiation dose, and this does include prenatal passengers, so please take this into consideration in your flight plans. So the space weather this week is definitely on the quiet side. We don't have any solar storms in the forecast, and we probably won't easily over the next few days or possibly throughout this entire week. So aurora photographers, well, you're just going to have to relax and enjoy and stretch your legs for a little bit. Even you aurora photographers at high latitudes, you're likely not going to get much more than just quiet green arcs. So relax, but definitely know that we've got those new regions rotating into Earth view here over the next few days, and things will change, I can guarantee it. Now, amateur radio operators and emergency responders, well, you know what? We've got that solar flux that's been kind of quiet lately, but it's now boosting into the high 80s and into the 90s, and it could be by the end of the week kissing the hundreds, right? The triple digits, which is always such a coveted thing. So enjoy improving radio propagation on Earth's day side, even though at the latter part of this week, you're probably going to start noticing a bit more noise on the bands, and that's due to those new players rotating into Earth view. But enjoy meanwhile. Now, GPS users, well, right now it's pretty quiet, and we don't have any storms in the forecast for you right now, so GPS reception both on Earth's day side and on Earth's night side looks pretty good, but I can't guarantee that's going to stay that way next week. I'm Tamitha Skov, the Space Weather Woman. Thank you for watching.
Okay, thank you, Tamitha, for that report. I'm glad that went through okay. This is VK3EKH, the official station of the Astronomical Society of Victoria. And now we'll go to. Unfortunately, I'm just going to put over a week of the podcast. I tried another technique to. The headphones are distracting me. Just put those off. That's better. So I'll wait until next week for to play that podcast. I'll make sure I edit the audio file a bit better. I did it on the fly just a couple of hours ago, and I thought I did it okay, but I don't know why I just got half of it. So, all right, never mind. Okay, let's at 10:40 we'll go into our next article, which I think I'll talk about cosmonauts, a story about Soyuz 23. So I've got a couple of pictures. I keep bringing up the wrong thing here. I've got a couple of pictures here of this. All right. So I might just indicate too that the when it comes to the solar report from Tamitha, of course, it's very visual. So for those folks that are stations that are only listening on 80 and 160, of course you miss a lot of the graphics that Tamitha has, so that's why I suggest that always listen to or tune into the YouTube feed if you don't have access to the television repeater. Alright, now how two cosmonauts almost died. There's a few Russian names in this, and I am definitely going to trip over these names, so bear with us on that one. I just thought I'd pre-warn you. I'll do my best. How two cosmonauts almost died after landing back on Earth. 45 years ago, an unplanned splashdown forced two cosmonauts to battle horrendous weather, and that left their capsule bobbing in a frozen lake for nearly half a day. You can just trust the Russians to get this. Anyway, let's continue on. It's a short article anyway. From the 1960s from the 1960s onwards, both American astronauts and Soviet cosmonauts underwent so-called survival training, as you do. This was to prepare them for the unlikely event that they landed in harsh or remote terrain, forcing them to fend for themselves while awaiting recovery forces. Few crews have ever had to rely upon their survival training, and many trainees have rolled their eyes at such exercises. But in 1976, the crew of Soviet Soyuz 23 mission underwent a troubled trip to space that ended with one of the most challenging recovery efforts in the history of space flight, demonstrating the eternal value of preparing for the worst. Soyuz 23 was commanded by Vyacheslav with Valery Rozdestvensky serving as a flight engineer. The mission was intended to be straightforward. The pair were to launch from the Cosmodrome at Baikonur in Kazakhstan, dock with the Soyuz 5 space station, and stay there for 1 to 3 months. Soyuz 5 was the latest in a series of highly successful orbiting Soviet space stations that fulfilled both civilian and military purposes. Although Soyuz 5's mission was almost purely military in nature, it was the first space flight for both men. The prior mission to Soyuz 5, Soyuz 21, ended abruptly when cosmonauts Boris Volynov and Vitaly Zolobov were forced to rapidly abandon the station. They had smelled acrid fumes and feared that the atmosphere had become poisoned. The air, which was contaminated with nitric acid, would eventually be vented before the next crew arrived, of course. But then Zadov and Rozdestvensky blasted off for Soyuz 23 on October 14, 1976. It marked what was essentially the last part of their mission that went according to plan. Now I've got another picture here of the two astronauts in question here. Let me just go back to vMix and bring up the other couple of pictures here of the two astronauts. Oh look, the audio still stayed on. Isn't that funny, Ian, how that happens? Alright, back to the article. This is VK3EKH. So, an unpleasant and unattended splashdown. As Soyuz 23 approached Solar 5, the automated docking system failed. Soviet dockings between spacecraft and stations were largely automated, and most cosmonaut crews of that era were not trained to manually approach and dock. And while attempting to get in position, the cosmonauts used a significant amount of their altitude control propellant, further worrying ground crews. The docking attempt was effectively scrubbed by ground control, and the two men began to make plans to return to Earth. Zhukov and Rozdestensky waited a day in orbit before commencing their deorbit burn when the landing window opened. But as the men descended, they were unaware that they were heading straight into a blizzard with extremely high winds. After their parachute deployed, the men expected to make a landing on terra firma, as had all Soviet craft before them. But rather than with a thud, they landed with a splash. Soyuz 23 has fallen right into the middle of a then partially frozen lake, Tengiz in northern Kazakhstan, a body of water that covers more than 500 square miles or 1,300 square kilometers. The Soyuz 23 descent module, now floating on its side, was dragged to and fro by the parachute in the water. The capsule periodically submerged under the waves. The temperature outside was far below freezing point and the weather conditions were harsh. Unaware of how far from the shore they were, and hoping that they would be rescued quickly, the men changed out of their space suits into the more comfortable and warmer flight suits. The Soyuz capsule is extremely cramped, even with just two of its maximum 3 crew members aboard. That's why the act of changing clothes alone took Zhukov and Rozdestensky over an hour and a half. By the time they changed, darkness had arrived outside. The men bobbed in the cold descent module, surrounded on every side by miles of freezing water and unforgiving weather. Complicating matters further, their reserve parachute later deployed as a result of mechanical failure, threatening to completely submerge the capsule. Due to the limits of the oxygen system aboard Soyuz, the men only had a few hours of breathable air remaining. Remembering their survival training limited their conversations to reduce oxygen consumption. At a bit of fuel to keep their energy up, and waited out. They also made sure to turn down the heaters to prolong the descent module remaining battery life. Meanwhile, Soviet recovery forces risked their own lives by flying straight into the storm to try and locate the craft. One helicopter managed to spot the cosmonauts' capsule in the water, but the wild weather prevented them from holding the position long enough to lower the rescuers and attach a recovery line to the spacecraft. Attempts to reach the cosmonauts by boat had also failed. After exhausting their resources with little progress to show, the rescue was put on hold until the next day. Some assumed the men were either dead or would die before morning, given the extreme cold and limited oxygen supplies. And as their exhaled carbon dioxide continued to build up in the cabin, Zhukov and Rozdestensky sounded increasingly strained and confused in communications as they continued to approach the point of blacking out. With the severe weather waning just before dawn the next day, a team of rescuers finally reached the capsule by boat. A short time later, a helicopter arrived on the scene and secured a line directly to the descent module. The rescuers agreed that the quickest course of action was to simply tug the descent module to shore, but such a procedure had never been practiced and let alone tested before. With the severe weather waning just before dawn the next day, a team of rescuers finally reached the capsule by boat. A short time later, a helicopter arrived on the scene and secured a line directly to the descent module. The rescuers agreed that the quickest course of action was to simply tug the descent module to shore, but such a procedure had never been practiced and tested before. I think I read that before, didn't I? Despite the dangers, they decided it was their best option. The process, which took almost an hour, was extremely hard on the cosmonauts within the descent module, which occasionally would be forced completely underwater while it was being pulled along. Still, it worked. Half a day after splashdown, the men finally emerged from the spacecraft coated in ice both inside and out, and set the foot back on solid ground. Zhukov and Rozdestvensky officially received public honours for their perilous mission, but behind closed doors they were largely blamed for the failing docking with Soyuz 5. Neither men would ever fly into space again. Rozdestvensky died in 2011 at the age of 72, while Zhukov, now 79, is still alive to this day. Soyuz 23, like Apollo 13, could be called a successful failure because the planned mission was never accomplished, yet the men all lived to tell the tale. And Soyuz 23 in particular serves as a warning to astronauts of all nations. Survival training, while unlikely to be utilised, may one day save your life. You're tuned to ASV Radio, VK coming to you from the studios of VK3CSJ at 9 minutes to 11 o'clock. Let's see, I know there's another interesting article I've got here, and something to do with radio astronomy. I always like to try and throw in a radio astronomy article. No chat on the window. I've got Cassiopeia and John up there, but where is everybody else? Usually there's a lot of people that come in on the Discord chat window. I'm surprised how quiet that is tonight. Alright, the next article I'm going to squeeze in here is to do with forgetting space weather. I know I've just had that with Timothy, but I always like to finish off with space weather. Okay, the true nature of the candidate ET signal from Proxima Centauri. Now, I've had that article a few times here on Friday night about this potential signal coming from Proxima Centauri, but here's the beef. Courtesy of Sky and Telescope magazine. I've actually got a picture here of Parkes Radio Telescope, which I'll bring up as well. Why not? It's there. There it is. And of course my audio fades. Funny how that happens. Human-made interference, not extraterrestrial technology, is responsible for the first candidate signal of interest detected by the Project Breakthrough Listen. It's called BLC-1, and it's the closest we've ever come to finding intelligent alien life. In 2019, astronomers discovered a radio signal that appeared to come from Proxima Centauri, the nearest star to the Sun. Though the signal was clearly unnatural in origin, it bore no obvious mark of humanity. The scientists named it Breakthrough Listen Candidate, or BLC-1, after the state-of-art search for extraterrestrial intelligence that made the detection. Until now, no one knew its true nature. In a pair of articles published in Nature Astronomy earlier this week, members of the Breakthrough Listen team reported that although BLC-1 almost perfectly resembles a true alien signal, new tests indicate it is of human origin. BLC1 is, in my opinion, the author here, the most compelling signal of interest ever, says Danny Price, the International Centre for Radio Astronomy Research. I've met Danny, contributing researcher on both studies. It has almost all the characteristics we expect from the techno signature, meaning evidence of the use of technology. This is no mean feat, he says. There are several ways radio searchers check whether a signal might truly have come from an alien civilization, and BLC1 is the only one that checked all the most important boxes. First, BLC1 is narrow in frequency, a tone purer than any natural process could produce. It is also clearly made by technology. Second, BLC1 was only detected when the telescope was looking at Proxima Centauri. That made it less likely to have been caused by human radio interference. But what really made BLC1 exciting was that its frequency changed, for a similar reason that an ambulance's siren sounds high-pitched when it comes towards you and lower as it moves away. A radio signal from outer space will change frequency depending on the transmitter's velocity relative to the Earth. BLC1's frequency drifted exactly like it would if it were being emitted by something moving within the Proxima Centauri system, like a satellite or planet. Put that all together and you get a telltale signal, one that resembles a narrow, intermittent waterfall cascading down your screen. As Price describes it, seeing the signature captured through breakthrough teams' imaginations, it's the first signal we've seen that has warranted serious follow-up, he adds. But with Breakthrough Listen observed Proxima Centauri again in 2020, and yet again exactly 2 years after the originating detection, BLC had disappeared. Something was wrong. Yet there were no tests left, no tests left in the old playbook. If the team was going to find where BLC came from, they had to invent new ways to look for clues. A bit of a needle in the haystack. There are no known electronics on Earth that intentionally transmit at BLC's frequency, so one of the first places astronomers looked was space. They checked satellites, space probes, and even asteroids, which can reflect radio waves from Earth. When that search turned up dry, they looked at possible routes around the observatory for anything that would have theoretically produced the interference. Someone strolling around with a device in their pocket, a car on the freeway, or a plane on the horizon. Any of these might have been able to mimic the drift of a signal. But when the team charted all the potential paths a person or vehicle might have taken nearby, they found that none could explain BLC1. The team tried a new strategy. They searched for all the lookalikes. If BLC is not unique, if it was also detected when the telescope was pointing somewhere else, then it wasn't ET. Searching all the data they had taken on hundreds of other stars, the team turned up a few dozen signals that drifted exactly like BLC1, though around different frequencies. That's when I felt we had enough evidence to conclude that BLC1 was radio interference, Price recalls. With careful study, the team found that all of these signals could be produced by a signal electronic device interfering with itself, producing weak radio waves at a range of frequencies that just barely leaked into the telescope. Price's best guess is some piece of high-end electronics tens of hundreds of miles away. What exactly the device was is beside the point. What matters is that the new tools Breakthrough Listen developed will be really useful when they find another interesting signal, explains Michael Garrett, University of Manchester, John Rollbank Observatory, who wasn't involved in the study. We are really much more capable than we were a few years ago. If there is a signal out there, we are getting closer to being able Science Breakthrough Listen Science Breakthrough Listen has only searched about 1,000 stars. Out of their goal of 1 million, the project should have plenty of opportunities. Garrett is hopeful one day we might discover something that would really change how we view ourselves in the universe. Where does that leave Proxima Centauri though, you might ask? Even before BLC-1 was discovered, the system invited speculation of being inhabited. It's hosts of at least 2 planets, one of which is potentially rocky, like the Earth, and at the right distance from its star to sustain liquid water. However, recent observations of huge flares from Proxima have made prospects of life on the planet less likely. So Price, the question isn't theoretical. The only way we'll ever know, he says, is simply by looking and crossing our fingers. You're tuned to ASV Radio, VK3 Echo Kilo Hotel, the official station of the Astronomical Society of Victoria, with the regular Friday night news on anything to do with space and radio astronomy and ET. Okay, it is 11 o'clock, the hour is up, not that that worries me too much. I'll just quickly go across to space weather, if I can find it here. Space weather, there it is. And I've actually got a image here that I can also bring up from space weather. So let me just pop that up on the screen and let's see if we can get that working for us. Got to remember to put that audio in line. Alright, that should be looped. Okay, back to space weather. Alright, the solar wind is currently at 288.9 kilometers per second at a density of 7.5 protons per cubic centimeter. There are 4 sunspots on the sun as we speak. AR 2891, AR 2889, AR 2887 and AR 2886, I think it is. 4 sunspots on the sun, so the current sunspot number is 96. And the radio sun, measured at a wavelength of 10.7 centimeters, is at 112 solar flux units. 112 solar flux units, that's a big increase. So, Geomagnetic Storm Watch. A strong G3 class geomagnetic storm is possible on the 30th of October, when the CME from yesterday's X1 flare is expected to hit Earth's magnetic field. And that's what you're seeing on the image there on the screen as I speak. That is the CME, the Coronal mass ejection from yesterday's X1 flare. So what you're seeing there, bursting all those high energy atoms into space. And in fact, you can see that the camera gets a complete hit by a whole lot of cosmic rays. It just lights the screen up. Yesterday's X1 flare is expected to hit Earth's magnetic field. Such storms can spark naked eye auroras as far as south as Illinois and Oregon, not to mention the southern hemisphere. So yeah, there it is. The coronal mass ejection launched into space October 28. Exploding sunspot AR 2887 is heading almost directly for Earth. SOHO coronagraphs record the CME racing away from the Sun faster than 1,260 kilometers a second. So that flare, not flare, but that CME that you're seeing just there is traveling at 1,260 kilometers a second. And there's a lot of high charged particles just streaming towards Earth as we speak. The current potentially hazardous asteroids, as of the 29th of October, there is 2,226 potentially hazardous asteroids, and they're all sitting there as a big list. So you can go to spaceweather.com if you're interested to see which ones are bigger than the other. Alright, that's it for the 29th of October. This time next week it'll be a new month. We'll be finally into the month of November. My goodness me, how fast this year has gone, despite all the hassles. And let's just hope that as we come into to Christmas, things will be rocking and rolling, and no problems. But don't hold your breath. I mean, they're already talking about a new variant in this blasted virus, so yeah, that's another story anyway. Alright, I shall cease transmission on 160. So for all stations listening on 1865, thank you very much for taking the time to have your medium wave receiver tuned to 1865 kilohertz. We shall cease transmissions tonight. We'll be back next Friday to do it all again at 10 o'clock. So there won't be any callback on 160 as usual, but we will take a quick callback on 80 meters. And if I can find my pen, there it is. So standby stations on 160. This is VK3 EKH with VK3 CSJ on the microphone, concluding service on 1865, and standby stations on 80 meters. And as I should do, if you want to follow up any information about the Astronomical Society of Victoria, go to the website at www.asv.org.au. VK3 EKH is licensed to the Astronomical Society, and yes, and so visiting the website all will be revealed. So VK3 EKH concluding on 1865. Thank you for listening. Stand by. Stations on 80. Alrighty then. So turning up the volume. Don't all speak at once. This is VK3 EKH listening on 3541.
VK3 VIN.
Okay, I got VK3 VIN and VK3 Tango Juliet Sierra. There was another one there. Okay, got VK3 JR. G'day, Frank. Anybody else?
VK2 Sierra Tango Golf.
Okay, we got VK2 Sierra Tango Golf, and there is another VK2. They're a bit weak though. Just try again. Yes, VK2, and that is David, VK2 ELS. Yes, I just missed the E on that. All right, thanks, David. Okay, let's go to the top. VK3 VIN, VK3 EKH. Good evening, Ian.
Yeah, g'day, Clint. VK3 EKH, VK3 VIN. And g'day to the others calling back. Frank, you're tonight, and a little bit over, which is good. Good broadcast, thanks to Clint. Pity about the podcast, but these things happen. And Tabitha was in her usual glory and enthusiastic high form. I reckon that's worth about 20 dB on any signal strength. And I do enjoy her space weather presentation, although I don't always understand it. But it was interesting that she was pointing towards the various auroras. And although I haven't heard any down here or anything noticeable, let's hope that we do in the near future. There's nothing better than listening to an aurora. 5 and 9 plus 10 to 30, settling on an average of 5 and 9 plus 20 on 80 meters. Absolutely nothing heard on 160 tonight, Clint. But my aerial isn't for 160. And the PL990 is not set up yet. Interesting about the cosmonauts. Rather dramatic, in fact. But what an interesting article that was. Okay, thank you for the broadcast. VK3 EKH, VK3 VIN.
Thanks, Ian. VK3 VIN, VK3 EKH replying. Very good, Ian. You're 20 over 9 tonight. Good solid signal. Not a problem with your copy. And thanks for the for the kind comments there. And yes, a bit of a pity about the podcast that it wasn't going to go for very long. It was just a short podcast, and the quick listen I gave it downstairs on the laptop when I edited on the laptop downstairs, because what I do is I put the edited file into a public file, which I can then see here on the computer upstairs in the shack, and I just transfer it across. So I'm fairly certain that the whole file, audio file, was there, because what I do is Brendan's podcasts usually go for an hour, and they're just filled up with other things, and what I do is I just edit the main interview out that he does and just save that as a separate file, and I'm pretty sure I did that. I don't know why it stopped midstream, so never mind, that's just the nature of the beast, as they say. Thanks, Ian. We'll fix it up next week. We'll give it a proper run next week for sure. I might even put 2 podcasts back to back, perhaps. I don't know. We'll see. Thanks, Ian. Across to you there, Jack. VK3TJS up there at Chippenham. VK3EKH.
Yeah, VK3EKH. This is VK3TJS. Good evening to Clean, and good day to everyone that's joined in tonight. And I was quite comfortable listening in Shepparton, no problem at all, no 2 crackles, but beautiful signal and naturally the audio and everything else. So interesting broadcast, and hope everyone's got a reasonable weekend and enjoy the so-called freedom, as they say. So it's good job, Clint, and really nice clear audio. So thanks very much, and I might be a bit off frequent. I'm being on the door anchor, so you forgive me if I do. And catch up with you next time. VK3KH. This is VK3TJS.
Thanks, Jack. VK3TJS in Shepparton. VK3EKH replying. Very good. Thank you for the reports, and your signal is a bit stronger than Ian. You're about 20 plus, 20 to 25 over 9. So definitely a good signal down here in Tanari Warren South tonight. Yeah, likewise, thanks again for the kind of reports. It's all very good. Thanks, Jack. Frank, VK3JR, VK3EKH.
VK3EKH, VK3JR. Good evening, and good evening, everyone. And in your particularly strong ear, as 10 over 9 with the amp off, stronger than I've ever heard you, getting out very well indeed. It's good to hear. I loved Tabitha, of course. I'm really, and most of her predictions seem to come true. That's one thing about being a week early, Clint, is that you can at least get some idea of how the predictions have fared. I haven't anything special to report. Enjoyed the whole program as usual. Thank you for doing it. And the exoplanet confirmed is 4,572, which reminds me, I wonder if you've heard from Mr. YJQ of late. Haven't heard him on. Hope he's okay. VK3EKH, VK3JR.
Thanks, Frank. VK3JR. You're 30 over 9 here tonight, so a bloody good signal down here too. VK3EKH returning, very good. I think you said 4,572. So actually, I went looking for the apps for exoplanets, and I did install 1 or 2. I haven't played around with them though. I'm not too sure if it's the same app that you look at. It's probably the same one that Steve has. No, look, there was a radio astronomy meeting a couple of weeks ago, which unfortunately I didn't sit in on. But I know that I'm pretty sure Steve was part of the radio astronomy meeting for the ASV. He did send an email out to the ASV group, radio astronomy group, a couple of days ago. So he is about. He is up to no good. Just joking. But he is around, and the problem with the problem with this time is that he often gets very tired on a Friday night, and he often has a tendency just to hit the sack early. So he might start off listening to the broadcast, but it doesn't hang around. So he is getting he's an old man. So there you go. It's okay, Steve. Anyway, all right. There you go, Frank. Yeah, but he is around, and I'm hoping that now that the restrictions for travelling into Victoria have reduced, probably within the next 4 weeks, I'll be catching up with him up there at Heathcote, because we do have a working bee that needs to be done up there on the 8.5 metre radio telescope, and I'm pretty certain we'll catch up with him on that particular day, so very, very soon. All right, across to Stephen. I think it's Stephen. VK2 Sierra Tango Golf, VK3 EKH. Go ahead.
VK3 EKH on the group. This is VK2STG. Good evening, Clint. I think I got the name right. You said to me if my name's correct, Stephen or Steve. I'm located in southeastern New South Wales, about 50 km down the Cooma. And I'm afraid by no means irregular. I think I've called back once before. Actually, I'm usually asleep. I'm usually in bed at this time, but I was up a bit late this evening. I was just tuning around the band and came across your broadcast, which is coming in very nicely up here in New South Wales. You're about 10 dB over 9 on this band, and about an S8 to S9 on 160. Competing with the static a bit, but quite reasonable. So I'll keep it short because I didn't catch much of the broadcast, but just thought I'd let you know that you're putting out a great signal, and thanks for including me in the callbacks. VK3 EKH, VK2 STG.
Good on you, Steve. VK2 STG, VK3 EKH returning. Yes, good on you, Steve. Thanks very much for calling in. You're 5 over 9 plus 20, 15 to 20. You're averaging between 15 to 20 over 9. And we're just using a normal Pro 3 756 Pro 3 inverted V dipole, 100 watts, both on 160 and on 80 meters. That's our setup here. In fact, more information about the society or the broadcast or the station, just go to qrz.com. Actually, just type in VK3 Echo Kilo Hotel in the search on qrz.com, and more will be revealed about what goes on here. A couple of pictures as well. But yeah, this broadcast has been running since 1988. Every Friday night at 10 o'clock it kicks off. So we've been around for a while. Although I haven't been. I've only been doing the broadcast myself for about the last 11 years, 11 or 12 years. But previous to that, Russell Ward, VK3DRW, was the host for the broadcast, and he only did it on 80 meters in those days. He used to occupy the air for about 40 minutes or so. But I took over the microphone in 2008 or 9, I think. I can't remember now. So I've slowly introduced other transmissions, 160, and thanks for the report on 160. That's good. I'm interested. That's really great that you were hearing something up there. That's a vertical antenna that I run on 160. It's a Hushcraft MA160V. I think is the number on it. Top loaded antenna, capacity HAP, and all that sort of thing. And yeah, it stands about 45 feet tall and sits about 6 meters away from a flowing creek. So the ground conductivity is pretty good where it's located, probably about 60-70 meters away from you here. But yeah, every Friday night the broadcast goes, unless I so desire not to show up, which usually I give plenty of indication to folks the week before. So yeah, there it is. Thanks, Stephen. Very good signal from you. I'm quite happy with that signal coming in from Bungabi. That's how you pronounce that. All right, now we have David. A bit weak tonight, David. I'm pretty sure it's David. VK2 Echo Lima Sierra, VK2 ELS, VK3 EKH. VK2 Lima, VK2 Echo Lima Sierra, VK3 EKH returning. Yeah, the lightning crashes are a bit strong on you there, Steve. Sorry, David. I think you gave me a 5 and 9 report tonight. I think the report you gave me was 5 and 9, and something about hailstones as well. I think there must have been some local storm up there with hailstones. I think that's what you were saying. Yeah, look, I know there's been some pretty severe weather up there in New South Wales in recent days too. We've just gone through a pretty windy situation here in the last 24 hours. Cyclonic winds. I think the maximum wind speed down here recorded on some device was about 145 kilometres a second, which puts it up there into destructive winds. We've had trees fall down everywhere, and there's been a couple of Nelly towers that have gone for a bend. Fortunately my two towers survived the wind this morning. Yeah, so pretty stormy conditions happening around the country, that's for sure, David, and I'm a bit worried about those hailstones, because some of the hailstones you guys have got up there are the size of golf balls, if not larger. That's a bit scary. Anyway, thanks, David, for calling in. Signal is a bit on the weak side. I'll give you a 4x9. You're peaking about 9, but the lightning static is really causing issues as it would. All right, I'll take one more listen on the frequency. If there's any other stations, this is VK3 Echo Kilo Hotel. There's another station there, but you're pretty weak. Just try again. Yeah, difficult copy. Can anybody else hear that station?
I can hear something, VK2HTG, but it seems to be off frequency or wrong sideband or something.
Things make you go, Yeah, I think it might be a little bit of signal coming in from Asia or fishing bait or something like that. I think that's all that might be. All right, that's it. I'll close down for this Friday at 11:22 local. This is VK3 Echo Kilo Hotel with VK3 Charlie Sierra Juliet on the microphone. Thank you very much, everybody that's tuned in and listening tonight on the video stream and on the Melbourne Television digital repeater, VK3 RTV2. Thanks for watching, and we'll be back next Friday. In fact, I've got all next week off, actually, as it turns out, because it's Melbourne Cup next Tuesday, for what it's worth. I believe I've got a horse backed through our company that I work for, so I might be lucky next Tuesday, might not. But as it turns out, we've got the whole week off next week, so I'll be up to doing hopefully some things if the weather behaves itself. So this is VK3 EKH. For more information about the society, again, go to www.asv.org.au. That's the Astronomical Society of Victoria, asv.org.au, to investigate the website. And of course you can just check out the qrz.com page for VK3 EKH and VK3 CSJ if you wish. So on that, we shall say cheers and beers. That's a horrible term, isn't it? This is VK3 EKH concluding transmission on 3541 kilohertz. Cheers everyone, thank you for coming back. I'm losing my voice. Cheers everyone. All right, and I shall conclude the YouTube stream. So all stations on that've been viewing the YouTube stream, thanks for watching, and we'll be back. I forgot to mention that just a moment ago, but we'll be back on Sunday morning to do the WI broadcast. Thanks to Bevan, VK3BD's visual representation of the WI broadcast. So 10:30 on Sunday morning, and followed by the Old Timers Net, the Old Timers radio news bulletin is also ready to go this Sunday, and we also feature a live video from Ian, VK3JS. He's done another live video of him talking and doing reading of an article. So that'll be presented next Sunday morning after the WA broadcast. So including a repeat of Timothy's solar report for what it's worth too. Wow. So that's it for the YouTube. Thanks folks for watching, and everybody up there on the chat window, Cassiopeia, Nebs, and John, Mr. BLX. I don't know where everybody was on the chat window. It's been exceptionally quiet tonight, very unusual. Anyway, let's close the stream down. So cheers to everybody watching the YouTube.